So we are going to cover chapter 3, and so this is the agenda for the chapter 3. So we're first talking about how do you choose machine learning model? Like there's so many models. How you start from scratch to do a machine learning model? That's the first thing. And second thing is we are going to talk about what is pre-trained model, which means nowadays you guys use GPT, use Google Bird. You don't want to start from scratch. You want to some model people have trained. So you guys use like a well-built model, pre-trained model, and we talk about that. And then we talk about large language model. How do you use large language model? Of course, everyone is using it, right? But how you use it for more sophisticated jobs? How you tune it? Like you can customize the model into something you have unique needs. That's what we want to talk about. And also we have some like evaluation homework. So basically, once you've done the project, once you've done the chapters, sometimes how to evaluate why some model is good, some model is bad. How to evaluate? Like for our class, you take exams to evaluate your understanding, but the machine has to take an exam too, and you have to grade the exams to see how machine is doing good or doing bad. So these are all the stuff you guys need to focus on. So basically, I will spend some time on the first one, how to do the model build up. This is number one, very basic stuff, and then pre-trained model. I will have a video, so you guys watch a video for the pre-trained model, and how we use large language model to cater to your unique needs. We'll talk about that, and also for the evaluation, we will touch a little bit about how to evaluate model performance. But you can rely on the exercise on this value how to evaluate model machine learning models. So when you do any AI model, when you do any AI machine learning model, you have 4 steps. The first step is called the feature selection, which means what kind of data you use to fit in AI, right? This is one. The second one is model selection. You want to use GPT, or you want to use Llama, you want to use Google Bird, and Claudia. There's so many models going on. Which model you use? That's the second thing. The third thing is model fine-tuning. If you use GPT, if you don't get the answer you want, that means what? The GPT is not smart enough. It's not intelligent enough. So you have to tune the model to make the model to answer the questions. Have specific questions. The model has to fine-tune the model to answer like exactly the question you want to ask. So that's called the model fine-tune. Then the final one is model evaluation. So any machine learning has these 4 steps. I'm not talking about just for business school. I'm talking about even for computer science, even for OpenAI. Everyone, as long as you use machine learning, you start with the 4 steps and you go one by one. So we are going to talk about one by one, like what's the 4 steps, like, and what does that mean? So basically, the idea is you have to know what data you give to AI. That's number one. What number 2 is what model you choose. Number 3 is how you change the model. You fine-tune the model to make the model to answer some unique questions you have. And number 4 is how to evaluate the model. Okay, this is a very roadmap of AI. Like you have to understand, this is not just for business school, for everyone, for computer science, for engineering school, and we're going to talk one by one. So, but just at a higher level, what's the advantage for us? So you can see the slides here. So what data we feed into AI? Garbage in, garbage out. You guys heard of that, right? You give them garbage out. So I think what you want is you want to give the AI domain knowledge. So you can tell AI, so let's say if I predict stock price, if you predict stock price, what data you will give AI to predict stock price? So in that sense, you have the domain data. If you know accounting, if you know finance, and then you know what data you fit in AI. And that's the advantage we are talking about for business school. Okay, and the second one is model selection. We use Llama, we use GPT, we use Claudia. This one was important earlier, like 5-6 years ago. We have to do a lot of domain. You have to have a computer science to do the model selection, but it's much easier now. Everyone just use Llama or GPT. So it's kind of all the model become unified because of large language model. Before you have to learn LSTM, gradient boosting, all the different model, tree structure to know the model selection. But now this one become unified. Like everyone converts to one model, you just use that one. So this one has a high hurdle earlier, but become easier model selection. The model fine tuning is something beyond some of the course, because this one does require some computer science programming skills in order to fine-tune the model. But in this course, we'll talk about what you can do in a simple way. Like without programming, can you fine-tune the model? And later on is model evaluation. Is also kind of straightforward. So you can see that the most of strength business school students have will be here. What data you fit into AI? If you fit the right data, AI will perform well. If you fit in the wrong data, AI will do bad. And you have the domain knowledge to test. So if you look at all the computer science paper, when they do the stock return prediction, do you know what data they fit in? They use the historical stock to predict future stock. So that they will do that. So, but you look at all the finance paper or accounting paper, what data accounting and finance scholar use? We use a variety of data, not just previous stock price. We use conference call, press release, images, Twitter data. You can see that because of your domain knowledge, understanding all these capital market data. So you can see that for computer scientists, they only focus on the historical stock patterns. That's the only input they use. But for the accounting finance, you guys put press release, annual report. So many data we covered in textbook, you put in as input of AI. So you can see that this is very unique for the domain experts to kind of to highlight your strengths in the area. So so what's the data one? Data one, the stage one, how to do the feature selection. So number one is called data cleaning and the data parsing and the feature selection. So what is data cleaning? Data cleaning is you have to clean the data. You have to eliminate some like boilerplates. You have to handle missing data. You have to do some of these kind of just take care of the missing variables. This is data cleaning. So if you guys remember the analyst report we talked about in the first chapter, you guys remember analyst report. In the analyst report, there's a half-page disclaimer. Disclaimer means, said, this is my recommendation, but I don't hold any liability. If you just follow my suggestion, there's a half page or 1 page of disclaimer. So these are the useless information, right? This information will not be important for us. So this is stuff you have to clean. You take it out. You have to take it out. So this is some of the disclaimer, some boilerplates you have to take out. So right now, the large language model can make this much easier to do that. Before, what we do is we use regular expression to get this kind of disclaimer and manually take it out. But now the Llama GPT can help. You just tell them, we don't want this. The large language model can easily do the data cleaning for you. And this is one of the exercise you guys will do. It's one exercise you guys will do, how to do the data cleaning. And the second one is parsing. So what is parsing? So you convert unstructured data to structured way. That is parsing. So later on, you can see the example. For the conference call, right? The CEO did the presentation and the analysts ask questions. So it's Q&A. So how you pass the unstructured transcript into a structured way? You have a question is one row, answer is one row, question is another row, answer is one row. So this as passing also, you guys will do that. And now identify the feature selection, means what kind of data you want to put into AI. So do you want to use, like earlier I said, like computer scientists, they use the historical stock price as the input. Of course, it's important, but there's many other variables, right? Like I said, the conference call can be useful. The annual report can be useful. Okay, you have to identify the data first. And then another interesting thing is, among the conference call has so many information. What do you do? What kind of conference call content do you want? So earlier people will use what? Use sentiment. They use sentiment of the conference call. But the ages has been gone. What do we want? The conference call has many other information. For example, they talk about the political risk. They talk about the climate risk. They talk about operations. They talk about the sales growth. They talk about operational changes. So all these domain topic you can put as input to AI. And you need understanding this domain knowledge in order to tell AI, these are the useful information. These are the useless information. So you can see that the stage 1 is there are 3 steps. So you have to clean the data, and you have to pass in the data from unstructured to structured, and you have to do feature selection, which means you have to identify data first. Like, do you guys remember in the first chapter we have an annual report? Annual report have item 1. Item 1 is about what? Business description, right? Item 1A is about what? Risk factors, right? Item 7 is about what? Forward-looking statement, right? You have all these items. When you put this one into a chat GPT, you have to know for this particular question, item 1 is only relevant. You don't need item 7. If you can tell AI the relevant section, instead of just put a whole annual report into AI, AI will do a better job for you. So what I'm saying here is, if you just put the garbage in, you put all the annual report in, AI will get confused. Oh, so many sections. I don't know which one is important. But if you can say, okay, for this particular question, we only need item 1 because we need a product description. We don't need something else. So this kind of domain knowledge can help to give the relevant input to AI, help AI to deliver better performance. So this is stage 1. So stage 2, how to do the model selection. So this is something you can see that the model selection based on your question. So each model can be evaluated, and ensemble learning is one way you can do that. And this is something you have to do by learning by doing. So you guys can see one of my paper. You guys in a paper. So in that paper, what we do is we have compare several models. So we have the support vector machine. We have the random forest, we have the gradient boosting, we have a LSTM, we have all these models. So why we have to choose all the models? Because each model has their strength and the weakness. So for example, LSTM is good at handling time series data, and the gradient boosting is good at handle the nonlinear relationship. And the decision tree, the support vector machine is the best linear model you can find from machine learning. So you see that each model has their strength and weakness. So what model you should choose based on your research question and the data. So for example, I want to predict stock returns, but a lot of my data has a lot of nonlinear relationship. I may choose gradient boosting because gradient boosting can handle the nonlinear relationship. And if your data has a long time series, you want to choose LSTM because LSTM can get the time series pattern from the data, help you to predict future stock returns. So what you need to do is you have to understand the strengths of each model, and you have to understand the nature of the data. You have to understand the nature of your question. If you understand all the 3 dimensions, you can pick up the best model for yourself. So you guys can see the pattern, right? So like I said, when I choose a model, so which model I choose depends on the data. If the data has like a huge time series pattern, I will use LSTM. If the data has a lot of nonlinear interaction, I use gradient boosting. These are the examples. So you choose a model based on your data nature, based on your questions. That's how you choose data. But in that paper, what did? We did ensemble. What does ensemble mean is we want to put all the machine together, learning together. I want the strength of each model. So basically, I want all of them. I want the time series handling ability from LSTM. I want the nonlinear relationship from the gradient boosting. I want everything. Greedy, right? Very greedy. I want that. So I put all the machine together and ensemble them. And then you guys see the current search engine, the Perplexity. So what they do is they ensemble. So you see the Perplexity, they have GPT, they have Llama, they have the Cloudy, they have all the large language model. They ensemble together to find the best answer for you. So this is also another example of ensemble learning. So basically, for each model has their strength. You have to use your domain knowledge and model knowledge to choose the model. But nowadays, people do is just put them together people want the strengths of each model. So this is a typical idea of ensemble. So, and then you go to the model evaluation and parameter tuning. So what does parameter tuning mean is the model, just the answer, you ask GPT didn't give you a good answer. So you have to tune the model to make the model understand that you have a unique demand, unique needs. You have to fine tune this. And what you do is you have to tune the model. So if you do the traditional neural network, some parameters like learning rate, batch size, and these are the hyperparameter. You can tune the model. And gradient search to do the parameters. So basically, so what you do is you have to do the loops. You have the GPT to do the test 1, test 2, test 3. So the AI can do a millions of tests, and the AI can figure out what's the best answer. So that's the gradient search. So you have the AI to find what's the right answer. When I say right answer, it's the weight. It's the weight on each model. So these are the parameter tuning, and the hyperparameter tuning is kind of different idea. That's the hyperparameter tuning help you to determine which parameter, how to tune the parameters. So these are the two different concepts, hyperparameter and the parameters. But the idea here is for AI. Normally, when we do the gradient search, you have to write a loop. You have to ask AI to take millions of exams, and from the loops of taking exams, AI can find the right answer, and then eventually you finish your training. So we'll talk more about this hyperparameter tuning or parameter tuning. And so basically you can see this iteration. So basically you can see the iteration. That's why I told you guys for the paper, I told you guys for the first 6 months, our model can only beat more than just only 30% of Wall Street analysts. But after 3.5 years tuning, we can beat more than half of Wall Street analysts, because we are tuning the model to make the model to understand this massive data, and the model can have intelligence. Sometimes it should become superior to some Wall Street analyst intelligence. That's the tuning process. And the last one is how to evaluate the model. So one big concept you guys need to understand is called cross-validation. So what does cross-validation mean is when you say the AI can take exams, you don't want AI to just even if AI can do all the exams well, it doesn't necessarily mean the AI can do the next exam well. So what we want is the idea that cross-validation is, let's say you have 100 exams. The idea is you randomly take out 10 exams out. You train the AI use the 90 remaining exams. And once the AI trained, and you use the remaining 10 exam to test whether AI is doing good job or not. So you don't want to use up the 100 exams to train AI. If that's the case, you don't how to evaluate the AI. So you always want to retain a random sample from your 100 exams. So you only use 90 exams to train AI. And once you finish the training, you use the AI to answer the remaining 10 exams. So, but one interesting thing you have to pay attention is the 10 exams has to be random. If the 10 exam is not randomly drawn, then it will be biased, because you don't want AI only able to answer the 10 questions. The objective is AI can answer all the exams, to do all the exams, not just the 10 exams. So how to make sure AI can answer all the exams, not just that 10 exams? You have to make the 10 exam random. If the 10 exam is a random exam, that means AI can answer most of the exams very well. So make sure the randomness of that the holdout sample is the key. So that's why we do the tenfold, which means we randomly choose 10% out, and we choose another 10% out, and then we choose the 10% out. We choose the 10% of the 10 exams 10 times, and then we get an average of the performance, how the machine can do well in every draw of the 10 tests, how machine can do well. So it's called cross-validation and tenfold. So so this is the example. You can see that. So this is the we divide the 100 exams into 20 each, right? So and then you use this as a training. And after training, you use the blue one cell to validate whether the training is finished. And then you randomly draw another blue one, and you use the rest to test the trainer AI, and you validate that the results is good. And you use this one, randomly choose this one, and use the remaining one to train AI. So you did this 5 times. If the AI can do good in each 5 times, that means AI can do it for any test. That's why we can verify the randomness of this kind of the validation sample, right? So what I'm trying to say here is, if you just do one, if you use this 80% of the training fold to do the for the split one. If you just using this for training to predict this the first split one, maybe it's just by luck. Maybe AI did this by luck, right? But if you did this 5 times, each time you randomly choose 20%, and then use this one to you each time you use random 20%, and each time AI can do well for the random 20%. That means AI can do good job for any test you can give in the future, right? So this is called a 5-fold cross-validation, and you can see how we do that, right? How we do that. That's the concept. That's the concept. The K-fold. K can be 5, can be 10, can be 2, right? Depends on how large is your training sample. So you can see that this is how we make sure AI can do good job, not just for that particular sample. We want AI to do good job for all samples. And then how do you do the model evaluation? It's the last step of this. How to do the evaluation? So we have 4 concepts, which are very important, and you guys will do this. So we have accuracy, we have precision, we have recall, we have F1 score. So what does that mean? So I'll give you guys a simple idea. Accuracy is, let me just maybe give you some of the analysis of accuracy. Means let's say I give you 100 images. There are 100 images. There's 1 image is dog, 99 images non-dog. Okay, that's the setting. Okay, I give you 100 images. 1 image is dog, 99 is non-dog. Okay, that's the setting. And you ask GPT or AI to identify which image is dog, which is non-dog. So this is the binary classification, right? 1 is dog, 0 is non-dog, right? This is a setting we have. So what does accuracy means? Accuracy means among all the 1, AI tell you how many are correct. So let's say the GPT give you there are 3 dogs, there are 3 pictures of dogs. In that sense, out of the 3, 1 is right, 2 are wrong, right? So that's the accuracy. That's the accuracy. So basically, among all the dogs a machine pick up, how many are real dogs, how many are not real dogs? That's the accuracy. So what's the precision? The precision is what? Precision is that's supposed to be dog, but AI make it as non-dog. That's the precision measure. So basically, how much dog AI are missing? That's the procedure. So what's the F1 score? F1 score is the average of the 2. So basically, if AI can get if AI say this is dog, and it actually is a dog, that's high accuracy. And if AI is supposed to be dog, but AI make it a non-dog, that's the precision. But average them is F1 score. So one question I want to ask you guys is, in the example I gave you, so one picture is dog, 99 picture is non-dog, right? If you, for a smart AI, what AI will do? What AI will do is AI will just suppose to say everything is non-dog. Think about it. If AI predict everything is non-dog, the AI will get a very high accuracy because they're just missing one thing, right? Missing one thing because they're out of 100, they only did 1 thing wrong. This only 1 dog is wrong. 99% of chance AI is correct because AI give you 100 non-dog. The AI is 99% right. They only wrong about the only true dog. AI is wrong, right? Only true dog is very wrong. So you can see that if you just rely on accuracy, it's not good. Because if you just look at the accuracy, AI can just tell you the 100 images are all non-dog. If AI do that, that's cheating. That's a cheap way. In that case, you get a 99% accuracy, 99%, because the AI only missing the only dog, but the precision is terrible because that's the only dog AI missed. So you can see that case, right? If the image has only 1 dog and the 99 non-dog, if you just rely on the accuracy, AI will just predict everyone is non-dog. They have a high accuracy and a low precision. Have a high grade, low precision. So in that case, it's not good. It's not good. So when you evaluate the models, you have to look at accuracy and the precision. Sometimes that's why people look at F1 score, the average of the 2. And this is most important for unbalanced sample. What do I mean by unbalanced sample? Means the case I just gave to you is unbalanced sample because you only have 1 dog, 99 non-dog, 1% of dog. That's unbalanced. So what is not balanced? If you have 50 dog, 50 non-dog, that's balanced. For balanced sample, and accuracy will work very well because it's already balanced. 50 dog, 50 non-dog. right? So also like what kind of evaluation you should use also depends on the nature of the data, right? If you have unbalanced sample, you have to rely on the precision. If it's balanced sample, you can have more weights on accuracy. So these are the examples how you evaluate a machine learning model. There's no good rule of thumb. You have to look at the nature of the data. You have to look at the nature of the data. So you can see the calculations, how we did that. But the idea is what I just talking about. And then, so this is the imbalanced sample. There's exercise you can do that. It's similar just what we just talking about. So you can see this case. There's a 150 the true positive and negative. So you can see that this is how we sometimes if you so in the imbalanced sample you can see that for a lot of emails, when you guys get emails, you can see that 98% of emails are not spam, right? Only 2% of are spam. So if you add machine to detect which one is spam email, which one is not, if you only focus on accuracy, AI will delete all emails for you. The AI will say, no, I'm sorry. AI will say every email is good email. Because if AI say all emails are good email, they only miss the 2% part, right? You guys see that? If AI just classify all the emails are good emails, non-spam email, they only get around about 2%, right? So if you use accuracy, they have a 98% accuracy. But the precision is terrible because they are not getting all the spam emails. So that's why for this unbalanced sample, you cannot just rely on accuracy. You have to look at the precision. It's more important for this kind of unbalanced sample. So the idea here is, how to evaluate the AI depends on the nature of the sample and the nature of the questions, right? So these are different stuff. And the data part, the pre-training part, you guys can look at another video. I created another video in the textbook. You look at the textbook. I have a whole video to explain what is sentence embedding, what is Google Bird, and what is the bidirectional. And we are just let's focus on this prompt engineering.